Hello everybody, it is Mike Levin on August 1st, 2022 at around 9:30 p.m. doing a live cast. And I figured I'd do a live cast on this one in order to force myself to get through this next round of work, which has been a trick for me. I am switching from a more traditional kind of Python scheduling to something called data pipelining. And before I do that, it occurs to me that the work I've showed you so far, when last we left off, I was in this Huey container, but when last we left off on the service work, the Linux service under a Linux container, under Windows, I had a simple wait, a while true. So let me just go there instead of explaining it, right? So I log out of Huey, which is one of the new containers I created. So I created the Huey container in anticipation of some fairly more complex work I'm going to be doing soon. But I did some really neat Python Linux scheduling service based on a simple wait loop. So let me go into that. I'm going to LXC stop Huey, LXC start Munchkin, LXC execute against Munchkin, getting into it and switching users, logging in as Ubuntu, and we can systemctl status pulse, see if it's running. Oh, it's enabled. So I will show you what it's doing when enabled. It's really cool because I can now screen ls. If it's running, then this thing is going, and I can screen reattach to pulse, and you can see the service running, although it only has one line output, and it's probably going to output a line every 5 minutes, so it's not going to be really interesting to sit there and watch that. So I'll control AD to detach from that screen, but there you have it, looking in on something running. And in fact, I'll make it more glamorous to see that running by vimming where I know it lives, which is in GitHub pulse.py, and it is every 5 minutes, I believe. So I'll just make it really obvious that it's running by making it go every 1 second. Now, if I went right back in, you would see it has no effect. So what I have to do is I have to sudo systemctl restart pulse. Now we go into the screen, and you can see every second it's writing out a timestamp. That's also going to a file. It's printing to the screen and it's going to a file. So this is being created by a while true loop in Python, right? So I'll just let it scroll to the bottom so that you can see we've got this lovely user interface where we can monitor the running of a service. I can do Control A escape, which allows me to use very Vim-like key commands to scroll up to the top of the service. So you can see I can go back in time into its buffer and take a look at it. We get out of this mode by hitting escape again, and you'll see the scrolling start again. There it is, the scrolling start. So we'll do Control A and D to detach. And since that's writing into this file and also writing into memory, because /tmp is stored in RAM, I will sudo systemctl pulse stop pulse. When command line completion doesn't work, it's always a indication you don't have it right, but I do. I have it right there. Okay, think. So that screen is no longer there. stopping the service gets rid of the screen to like peek in and monitor on it. But that's fine, because what we really want to do is, and I'll open 2 terminals to this. We don't need this one open anymore, but you'll see that we can have 2 different terminals open to the same. We don't need sudo, it's lxc, exec, munchkin, switch user, login, Ubuntu. So you can see we're now logged into this container from that terminal and this terminal, right? So I can go between these 2 terminals and do things against the same container. Anybody there? No? Oh well, let's see, make sure I really am streaming. I am. It's fun to do this as a stream even when there's no audience, because it forces me to just forge on forward and not get caught up on all the editing nonsense. So we are logged into Munchkin in these 2 locations, and we are going to change this Python script, which I have in my command buffer here. We're going to change this to be a lot more schedule-y, right? Because this is not really a schedule so much as every 1 second loop. What if you wanted something to happen at a particular time? This is just a few lines away from actually becoming a scheduler, and it's the great precursor to going to data pipelining. So data pipelining is what I did that Huey container for. But as I was reading over the documentation for Huey, I'm like, oh my God, at a glance, there's all these new concepts that I have to really internalize. Huey is basically a process of using Python decorators outside a function, okay? And then running a consumer, Huey consumer, and then the file that has those functions in it, and then basically whatever scheduling you've defined in those decorators is what will be used. So I could make something happen every minute, every second, or whatever. But the API is so different from what I've been using. But I realize what I've been using is going to be able to be adapted to this, but it's too large of a step. So I'm going to take a small baby step initially, which is pip install schedule. This is an alternative to data pipelining. It takes care of the scheduling piece without taking care of some of the other pieces having to do with, well, Huey is mostly having to do with scheduling. Some of the other stuff having to do with locations and language. Anyway, there's a lot of ways data pipelining can be created. It's essentially creating a convention that everyone abides by for both scheduling and how data is fetched and transformed and put into destinations. So in this video, I'm just replacing the incredibly primitive scheduling thing that I'm doing here with more intelligent scheduling. So we want to do it under the Python 3.10 virtual environment. So we do source, and what is the source? I'll just remind you, we have a directory called Py310. Inside of Py310, we have a bin directory, or yeah, I guess it's going to be inside bin, cd bin. Inside the bin directory, we have a bunch of stuff, including the actual Python 3.10 executable. We can refer to it as Python 3. This is also where pip resides for anyone that's interested. But the program we want is actually activate. And for anyone who's unfamiliar with this, you could take a look at the activate program, and you can see it's like a bash shell script. And so this source activate process is based on bash scripts that are created by venv. So clear, fine, clear. So I'm going to cd to tilde backslash, and I'll do control L to clear, so I'm not typing clear over and over. And source, where is that source? Well, it's relative to home in the Py310 directory. In bin, and it's the file activate. Now watch what happens to my requester here when I do that, my prompt when I do that. It changes to have Pi 310 at the beginning. It tells me I'm in that virtual environment that isolates the Python dependencies. So whenever you pip install, which is what I'm about to do, right? I did all this so I can pip install schedule per the instructions over here, right? I'm not sure if I need to sudo that, but I'll try it without sudoing. Okay, we're going to update the pip version here. You've seen me do this in earlier videos. You just pick up that command and you paste it. You can see it was installed successfully. I'm just updating the pip that's there as well. So now we have schedule in there, and we can follow the example they give. So we can import schedule. Now they also say import time. Oh, because of time sleep. So I don't really need that. I already have my sleep command. So this is kind of nice, but we will do that in another file just so that we keep this example around. So cd //GitHub pulse, right? We put ourselves in that directory, and now I cp, that's the copy command, pulse.py into scheduled pulse. Pulse scheduled. It's a little bit long, but it is explicit, right? So there's pulse, which is a busy loop with a wait while, and then there's going to be pulse, which is a scheduled pulse. All right, we'll go with that. Now I can vim pulse _ scheduled, and now I can do the import. I don't know if it's a from. It's just import schedule. Import schedule. Okay. Now this is the awesome part. It's that same while true, right? You got to understand these busy loops to turn things into services are busy loops. I will even keep the sleep one, because look at this. Look at this here. Sleep one. They have a busy loop at the bottom. While true, schedule run pending. Sleep one. Now, what does a scheduled event? Well, first of all, I keep saying first of all, we're no longer first of all, we're many of alls into it. But they bill this pip installed schedule, this module called schedule, out of the Python packaging index. They bill it as Python job scheduling for humans. So what we're really doing is we're taking that stupid busy loop that just did something every 1 second, every 300 seconds, every 14,000 seconds, whatever I was using, and it replaces it with a much better language. Schedule every 10 seconds, schedule every 10 minutes, schedule every hour. And what's it scheduling? Well, it's scheduling a function. What function? Well, here's a function written here. So I'll do that. Def job, but I'm going to print a timestamp because that's what I've been doing. Let's def job, define job, and that's an arbitrary name, by the way. It can be anything you want. And now what I was doing in here, I will just move up to here. I was doing a lot more indents than I was in the past. Okay, so oh no, that was the right amount of indents. I was just nested in deeper. So, oh, well, that means I actually need these 2 lines as well. Silly me. Caught an error I was about to make. So the job really is, getting a timestamp put in as a string, right? So the F string just means create a string of this. And so we open that same pulse thing, but I'll call that pulse scheduled, so it doesn't interfere with our other pulse file. And we'll print it and we'll drop it into there. Now, instead of that busy loop, right, instead of doing it every second, right, so in the past, this would be doing it according to the way I just had it. This would be the same exact thing if I called the job function in here, right? Every 1 second, In fact, we should probably test that, right? Yeah, I say we test that. I'll put another space here for all you pep-aters out there. And right quit. And we use a full Python path to get to it, right? So I guess we don't really have to, but it could be good practice since I'm going to do it this way in the scheduler, in the service anyway. Services use full paths. When we're in the command line here, we can do just short paths. So to demonstrate to you, I now know from looking at that, I can do Python 3 to get into Python. It doesn't have to be the full spelled out 310. The virtual environment takes care of that. So I could go Python 3 pulse scheduled.py. All right, I made a mistake in it. Let's take a look. No module named schedule, schedule, schedule. Oh, well, that's because I'm not in a virtual environment here. Virtual environments at work. Source. Oh, you know what? Let's do it because honestly, the service is not going to be in the virtual environment either. That is a wonderful reason to use the full path. So if I wanted that to work, I could just do source activate home / pi310 bin activate. Oh yeah, we don't use activate twice. I always do because source activate, it sounds so good. Source activate, but it's really source and then the full path to the activate file. And there's our virtual environment. And now this little command that I did, Python 3, that'll work now because you're in the virtual environment and it knows where to find it. Now I'm going to do a wonderful little demonstration that we can deactivate that virtual environment and still make it run just as well by using the long paths, right? The long path is /home /ubuntu /pi310 /bin and we saw there's a variety of things in there. Here we can use Python 3 just to keep it a little shorter than 310. And that is the exe. That's the executable. If it's not the executable, it's a symlink to the executable and is just as good as it. And then the file we're going to run is similarly, even though we're in that directory and we don't really have to do this, but we'll use the similar long path because services like these long paths. Home, Ubuntu, GitHub, Pulse, schedule.py. Again, command line completion tells you that you have it right. Hit enter, and there it is running again, just like it was running up there. We don't actually have to activate the virtual environment. It's a good piece of information to know. We could, by the way, also vim tilde. It's not home. It's just /tmp /pulse schedule. See, it's a new file in there. And these are the heartbeat pulses we wrote out to our new text file in TMP. All right, so it's very clear that when we run this program, it's outputting once per second. Let's override that with the schedule module now and just slow that down, and you'll be able to see that we're using the API for the schedule, for pip install schedule, to slow that down, to make it not boom, boom, boom every second by using schedule every however many seconds do job, right? That's the exact line. This would slow it down to once every 10 seconds. So we replace, and we can edit over here. See, now I have two places logged into that thing, and we can Control L to clear. We can source, no, we can just deactivate. I think it is best to not be in the virtual env at this point because we're going to do some system work, some system service work, which we won't be technically in the env. So cd GitHub Pulse vim pulse schedule.py, And instead of just a direct reference to job, we do a scheduled reference to job. Write quit. I don't even have to quit. I'll stay in that file because we go over here to test it. How fast do you think it's going to be? The first one will be after 10 seconds because it's been scheduled for 10 seconds, unlike old versions of this thing that I had done, which, I think that's been 10 seconds and it has not shown yet. So let's go over here and see what I got wrong. Schedule every 10 seconds, do job. The job is what was able to be run directly through there. Sleep 1. Sleep is in fact importing time. We are printing it. That's right. We should be able to see it, and it should also be going to the log file. Is it running? Huh. The pulse service has started, so it definitely started running. You can see that. That's that first line that's specified here. But it seems like this every 10 seconds is not doing what it's intended. Let's take a look at the sample code, make sure. Oh, schedule run pending. Doi! Oh, so where is the schedule? The schedule takes place outside. The schedule takes place just sitting here, not inside the while true. I'm scheduling. Oh my goodness. So how many people out there were shouting at me? All right, open your eyes, Mike. Don't you see what you're doing? Control C. So run pending. And you can put the schedule anywhere you want. Doesn't have to be indented. So there, you define your schedule right at the top. The service has started. We can put that here so you can see right away. I guess it doesn't really matter. But then you can start running your schedule stuff. This is every 10 seconds. I think, yeah, it's still the test we want to do. Long path, job is not defined. Oh, interesting. Do jobs have to be defined above the schedule? Take a look at the example. Yeah, see, job is defined up there. So jobs are defined and then the schedule goes beneath it. There is an order dependency here. And for the PEP-8ers, one more try. The pulse service has started, and I believe it has been scheduled for 10 seconds now correctly. And so in just a few seconds, we should see, boom, the pulse. And it's clear now that it's running every 10 seconds as opposed to every second like it was running up there. And now we have a scheduler. See, that's a Python scheduler. And you can actually just go read over the documentation now of scheduler and see all the various things you can do. There's more involved docs. That first thing was just the light documentation. And there's quite a bit you can learn about here. Use a decorator to schedule the job, pass arguments to a job, cancel a job, run a job once, get all jobs. This is not data pipelining. Pip install schedule is not Huey. Huey has its whole alternative scheduling system that includes retry delays and all the things that would be necessary in making sure a job queue gets finished properly, a job queue that has scheduling features. That's what this is all about. And so on a video to come real soon, I'll be doing essentially the same thing as you saw me do right here. You know, let me do two things. Let me alternate two scheduled things so you can see it. I will make the pulse go every 10 seconds. And then I'll just make another function that will be a lot like that. But I'll just make it a hello world program. And it doesn't really have to write out for this demonstration. It doesn't even need this. I don't even know why I copied and pasted that other function. Change word, hello world. But now we have another function that we can schedule. We have the hello function, and we can make another line in our scheduler. And, you know, I'll change the duty cycle. 5. So there will be a hello every 5 seconds and a, well, no, actually, let me change the, oh, well, what does it matter? Because I haven't changed the word here yet. A hello every 10 seconds and a pulse every 5 seconds. And then I guess the last thing after this is turning it into a service, right? Because right now I'm just running it directly as a Python command line. So it's 2 pulses and a hello world. 2 pulses and a hello world. So there's a 1 to 2 duty cycle going on between the two. So there's convincing you we have real scheduling. It's just different seconds I'm using here, but you get the idea. So we'll control C out of that and we'll turn this into our new service, right? So, you know, I guess why not do it over here, right? Because we're happy with this. And now we can sudo vim /etc/systemd/system/pulse, and we will change the reference from just pulse.py to pulse_scheduled.py. Should we do it before and after? No, we did it before and after. You saw that near the beginning of the video. We'll save, we'll quit, and then we'll sudo. Now, see, now that we've changed that service file, this is a point I made last time. I'm not sure if I hit it home well enough. We can't simply restart the service. Restarting the service would be fine if it were just the Python code. If we just change this Python code here, then restarting the service would be fine. But we changed this file that is the definition of how that Python file runs. And when you do that, you have to use this very special daemon reload command, and it's just hard to remember, and you just got to know it, right? Sudo systemctl daemon _reload. Does command line completion do it? It does not. No. Reload daemon, unknown operation. Go to my journal. Oh, hyphen, not underscore. I was very close. That was this one here, daemon reload. The word daemon comes first, then reload, and it's a hyphen. So now we can look at the service. We can start the service, right? It's not loaded yet. Systemctl status pulse. It's still named pulse, even though I changed what it was. Active failed. Well, we'll see if it works. Enabled, loaded, enabled. I thought maybe I had, that probably was the reason loading failed. I should have disabled it while I was changing it. So let's say pulse, no, it's sudo systemctl restart pulse. Now we'll check its status. That's better. See, active and running. And active and running means that when we do a screen -ls, we'll see the pulse here. And if we screen reattach to pulse, we'll see the output. And the output does in fact have the hello world the 2 timestamps, the hello world, which is genuine scheduling, right? This is scheduled every 5 seconds, and this is scheduled every 10 seconds. So 10 seconds, 20 seconds, 30 seconds, 40 seconds, 5 seconds, 10, 15, 20, 25, 30, 35, 40, 45. I could even have a counter. I could make a global counter and add to it. Want to see some global counter stuff? Yeah? Okay. As an added bonus, Control AD to detach. That's one of the hardest things in the whole process. You don't Control C out of that, you Control AD out of that. Boy, the screen keyboard shortcuts are one of the hardest things for becoming this level of I don't know, Python, Linux service person, whatever you want to call it. But it's more fundamental than web dev. It's more important than web dev. You can make more money probably in web dev, but understanding this stuff is control. You control that Frankenstein moment of pulling the power switch on your computers, and your computers start up. System D steps in and says, oh, what services should be running? And you control what services run. You can make anything start. You can have scraping tasks if you're an SEO like me that goes out and scrapes on a scheduled basis, performs a search in Google, does a screen snapshot, drops it into a location, emails it, whatever, right? You get the idea. So the last portion here, and I ought to check if people are with me, right? I am live streaming after all. There's no one there earlier. It doesn't mean there's no one there now. You are welcome to say stuff. If you have any questions, chime in. And I am going to, what was my bonus feature? Oh, yeah, a counter to show how many times a pulse had occurred, right? So we can edit the file here. I think we were doing it in this location. Vim schedule. Okay, so I don't know, pulse count, global variable. It's nice to put these global variables at the top, but because of PEP 8, I'm doing all these double spaces after your includes, double spaces between functions, but still it belongs here. And that would be pulse count equals 0. There haven't been any pulse counts yet. And then whenever it goes into the function, oh, I can do it for job or hello, right? They just do 2 different counters. Or I could, I guess, put it in here, but it makes sense to increment it each time a job runs. And we'll do it on the more frequent one. No, we'll do it on hello. Every 10 seconds it'll increment the counter. So that's a pulse underscore count. Now the old way of doing it, the very verbose way of doing it, would be equals pulse count plus 1, right? But all the cool kids know to do plus equals 1. You just add 1 to what it equals, right? So that's the easy way to increment a counter. And now that we're using F strings, we can just put that arbitrarily in here. We do another curly bracket, and then we do pulse count, close curly bracket, and I don't know, we can just do a space minus space, right? A way to show that there's a difference between the pulse count and then the timestamp, right? I'm sort of blending it right into the timestamp because it's a string. This is an F string that's embedding it into a string. That's why these 2 quotes are here. This is actually, just like, foo equals hello world, except these curly brackets say use the Python value for these variables because it knows to do variable replacement because of that F right there. F strings, all the biggest deal. It's one of the more modern Python features, maybe Python 3.6 or something came in around. So anyway, save that, go back here, and restart the service. Sudo systemctl restart pulse. And we only have to do this restart instead of the Damien reload because I only edited the .py file. Now let's peek in on that. Screen reattach to pulse. Oh, might have screwed something up. Oh, global. I should probably put the word global in here. Global pulse count. I don't know if that's what kept it from reloading properly. Yeah, it was. Yeah. So sometimes when you use a global variable, you have to actually define the fact that it is a global variable. Oh, and then it terminated something. Yeah, all right. That is a sign of something going wrong, by the way. When that screen terminated, that means the syntax went wrong. And I can just, execute that here old school. Long pass, because I'm not in the virtual env. Long pass, it's always good to remind yourself. Pi 310, I know I have it in the copy buffer, probably on that other window, but from home, Pi 310, inside Pi 310 it's bin, inside bin it's Python, and there's a bunch of Pythons. You can hit tabs. You can even use just Python here. That's very interesting, right? They set you up. All right, so Python. I'm not controlling the variables quite as nicely by doing it exactly the same way, but this is extra bonus time, so we'll throw in the extra bonuses. And relative path, just local, pulse underscore, and your pulse has started. Now we'll see the error. Instead of just bam, you don't have a screen service anymore, it'll print out the error to the window here. All right. Oh, pulse count referenced before assignment. Local variable pulse count referenced before assignment. So I have the plus equals 1 somewhere in the wrong place. Shift 8. Yeah, I did it in hello, didn't I? But I'm using it here on this printout. All right, I'm talking out of both sides of my mouth now. I guess I have it in the, and it'd be nice to have it set to 1 before the first time you see it. So I'm doing it on the thing that happens every 5 seconds, right? Because job is happening every 5 seconds. Job is kind of a stupid word for it now. Let's say pulse. Search for the word job, make sure I don't have it left in there. Restart the service. And now it should work just fine. Peek in on the, so there's 1. Hello world, 2. So only the timestamps are going to create the increment, but there is a global counter now, incrementing every time that pulse occurs. And you can see, it's not incrementing on the hello worlds, but those are getting interspersed in every, 10 seconds, while this runs every 5 seconds. Ta-da! I don't know what to tell you. This is so powerful. Anyone following along with my tutorials now is getting a much better education than web dev, jumping to Node or Nginx or any of these other things that you could be doing when before you have your basic Linux service education. Did you know that your Nginx's and your nodes are all running under this context? They have to be turned into services. If they're not turned into services under Linux, they're running in some other half-baked way where something has to be kept running. You want to use the operating system's way to keep things running. Like, for example, if I Control-C out of this, screen ls, no sockets found, but I have this service set to restart itself every 5 seconds. So we do screen ls again, it's back, and I can go and look in on it, and there it is, restarted, and it's appending to that file, so all the appends are not lost. You can Control-C all you want, and it'll come back, and your log files, such as it were, you're kind of hand cobbled together. We should probably use Python's official log package, which exists in plenty of third-party log packages that bring pretty color coding and better APIs. But we handcrafted or cobbled together a log thing with open, right? Because every time you see one of these here, a with open command is also happening here. So it's two separate things, right? This is printing it to the command line. I can make that say something different than what gets logged. So I could use an F string again, right? We're talking about F strings. I just keep throwing in the bonuses. F string, double quote, open curly bracket, go to the end of the variable, close curly bracket, and say, is written to temp/pulse underscore schedule.txt. So that's like a for your information. It's just saying it's been written there, but that's not going to get written to the log. The log is just getting the timestamp there. So to see that in action, we can just Control-C out of that. And honestly, I don't even think we need to reload the service, because when you Control-C out of a service, it's got to reload it. That's the same thing as a reload. So there you have it. Is written to that location. But we can now look at that location and you'll see these words are not in there. So there's the 4.2. Scheduled.text. So another check. The latest is 7.4. And there, where's the 7.4? Make me eat my words. Oh yeah, Shift G to jump to the bottom. There's the 7.4. And you can see the counter starts over, because every time you restart the service, the counter starts back at 0. So you can see how many times you can see the turning on of that whole, global counter. You can see where I had the global counter wrong, and now you can see where I have the global counter right, and then you can see where I have reset the service, because that counter gets turned back to 1. I did it there. I did it there. How's that for a video? How's that for a live stream? Doing all this live. Oh, feedback. I can talk to people. Let's see what people have to say. Sherry, it sounds like you might have something flipped or out of sequence. I did, yeah. How would I explain this? Oh, to a farmer that barely exists in Pakistan or India, where he has to farm everything to himself. How would I explain that to him? Thank you. Oh, interesting. And then at the end of that, could you put a future? F, thank you. At the end of that, could you put a future? Oh, yeah, in the future. Yeah. So everything I've been showing has been rapid in order to show you how quickly this stuff can be in front of you for real timeness. But honestly, when you look at what schedule can do, yeah, you can put it as far in the future as you want. Minutes, hour, day. Oh, so an exact day. That's an interesting question, right? So these are all periodics, right? Or, they call these exact or periodic, right? So every 10 minutes or every Monday. So let's see. More examples. Yeah, I'm not sure if you can do it at a particular day, but all you would do is you would pip install some other scheduling package that lets you do that. So there's going to be scheduling packages out there that let you choose particular days. I don't know if this one does. I would have to read through the documentation more, except really this is not the end goal. The end goal is data pipelining, a much fancier way of doing this stuff, where you write functions and then you put decorators around that function, and these decorators set the timing. and then you run something. This is the part then that would get run as the schedule. The Huey consumer would get run as the scheduler, and it would consume these files that you've created that have these decorated functions inside of it. That presents to me a unique problem because, my things are not written as functions. My things are written as .py files. They're intended to be run as full py files. That py file can get scheduled. But I have the solution to that. That is my work tomorrow, to make a whole .py file exist exactly as if it were a decorated function. In fact, you could have a Node.js file. You could have JavaScript. It doesn't matter. You could have any file that can be run from Linux, which is everything. Everything can be run from Linux, basically. And then you could decorate a function that calls that external file. So a scheduler like this, so is that this here, scheduler like this, or a data pipelining thing like this can both schedule external files. Okay, so to answer your question, how would you explain it to a farmer? I don't know. This is such different context. I guess it's spellcasting. Do you believe in magic? So one of the things a magic user can do is make things happen at a certain time. Now, in this world, everything that can happen is kind of in the digital internet world. So doing screen snapshots of websites, how much would that mean to a farmer in India? I don't know. But if you had this connected to a water sprinkler, you could schedule the sprinkling of the water to irrigate your fields if you have that system out there. Anything that could be scheduled in farming could be scheduled according to this system. And if you need things to happen at a certain date, you would just choose the appropriate Python package that would allow exact date scheduling. Yeah, I'm just giving examples with schedule.py. It's one of my favorite ones, right? Pip install schedule. I'm demonstrating this to you because it's one of my favorites. And I'm using this one because my coworker at work, that's his preference, and I'm all about using what people like. So, but my problem was that, and this is interesting. This is not answering your question so much, but this is getting into a detail I need to deal with. Because the API of Huey uses function decorators, I need to put inside of one of these functions a call to an external Python py file. And that's why I have this GitHub, turn Python script into a function. Now, I already do this all the time, honestly. I didn't really need to look at this Stack Overflow page. But this person says, assume I wanted this morning.py to be called from another Python file. And everyone plays pile on the rabbit. Don't pile on the rabbit, the reference. Anyway, everyone says there's absolutely no good reason to run a Python script from another via popen, which is just a sub-process thing way to do it. Why can't you just import it as is? And you can do all of this native Python, but if you do use the external script executor, which is what was sitting here in my journal ready for a much more elaborate video today. I had a different video in mind, but if you refer to things externally like this, I could run programs, an external py file. I have a concept of one pulse planned, one pulse here. And so one pulse is going to be run as if an external Python program from the Python schedule.py, and that will be my way to get complete py files to run as decorated functions, because I can throw a decorator up there. I wouldn't in this case because it's under the scheduler system, but when it's under Huey, I'll be able to throw whatever that Huey decorator is in there. Huey decorator, which is how scheduling is achieved under that particular data pipelining package. So let's see if there's questions. Oh my goodness, Sherry, you're on fire. Oh, you're okay. Well, let me make sure I'm reading all of it because it goes up quite a bit here. Yeah, okay. I was starting from the right spot. You're 64 years of age, theoretical scientist, retired, had a hand injury, so you have traumatic brain injury now. Thank you for understanding. Thank you. I see that you can follow along. I appreciate that. Yeah, I'm these every time I do one of these videos, I choose between just recording it and uploading it and interacting with the users, and I'm happy to interact. This is really exciting. Yeah, okay. You on YouTube look up Pakistan trucks. It is a website. You're looking for the women in Pakistan for labor. Okay, yeah. Are you promoting? You have 100 students. Okay. None of them could speak or read or write English of their own. Teach them visually and only verbally. Thank you. Professors' names. All right. I am glad to talk to users, but everyone's going to have their own thing going on. As long as you're not talking bad talk, it's fine. You can get this stuff out there. That's fine. Yeah, it sounds like you got some interesting stuff going on. Python is universally applicable because it's cheaper and easier to set up a Linux computer than it is other types of computers. So you could use a Raspberry Pi. I know you're in Pakistan, but India is very big on cheap computers for learning, these little tablets. When America did the one laptop per child, India was like, we don't need that. We'll do it cheaper. And they did. It wasn't the greatest tablet, but, over the years, that was years ago. That must have been 10 years ago. But now, Raspberry Pi Zeros are like $5. Computers are virtually free. That doesn't take care of all the infrastructure to get it working and to get it on the internet. But the type of code I'm showing here is stuff that even the money-strapped could, sorry for the English idioms, but for even those without a lot of resources could get this code running locally. You need a certain number of things. Even with a Raspberry Pi Zero, you need a way to hook a keyboard and a monitor and power it. But then once you do, all these techniques are just as applicable on very inexpensive computers as they are on modern laptops. AI. So AI is definitely something you can start. These are not AI tutorial videos we're doing. We're getting there. But if you wanted to start on AI under Python, you can go ahead and start doing it today. I would actually recommend installing Jupyter Notebook. You see, I always have Jupyter Notebook as my second screen. My first screen is always my journal. My second screen is always Jupyter Notebook, or technically it's Jupyter Lab. And my third screen is a web browser. That's how important I consider Jupyter Notebook. And once you have this Jupyter Lab installed, you can, create new Python files, and you can do all kinds of interesting things here. A equals 1, print A, and A is still there. You can do A plus equals, that trick that I did for the global counter. And every time you execute that, you can see it updates it. So this is this wonderful learning experimental environment. And so the machine learning, there's machine learning lessons that are given out as Jupyter Notebooks from what you want is fast.ai. Actually, let's see if I have that right. Fast.ai? Yeah, fast.ai. Fast.ai has wonderful lessons that are Jupyter Notebook based and are very much geared towards new learners and cheap hardware. So a lot of the machine learning stuff these days requires you to go to the cloud and use all the powerful processing of the cloud to do your machine learning. But if you have access to hardware that has GPUs, game cards, if you have a game card or the built-in motherboard NVIDIA chip, you can do machine learning on a surprising amount of cheap and available hardware. And that's the way I would recommend going about it. There's books that are published. It's actually a book that's published as Jupyter Notebooks, and you can follow along. I believe it starts right there. Fast AI for PyTorch. All right. Other questions? Yeah. All right, that's where you left off. I definitely have made my points about, oh, there's other people in here. Very informative. Love the stream. Thank you. You're welcome, Deep Dive Stocks. I'm glad I noticed your input. If anyone else has anything to say, chime in, because this video is fully baked. Look, it's up to global counter 175. We could go over here, quit out, go back into that, Shift G. There's 175, 176. So while not technically using the log file package from Python, I have just written out a timestamp to a file with a counter that achieves much the same thing. Can you imagine how much control you have now over stuff? No longer is that just a stupid wait loop with every 1 second. You can schedule these things per Sherry's question. Can you schedule something in the future? I believe Sherry was talking about a particular date in the future, but if you're just talking about like next Thursday, yeah, you certainly can, you know. It also supports decorators. It doesn't force you into decorators. That's something that I found very appealing about this. And pass arguments to a job, right? So even though you're referring to the function with out the open close parentheses with no seeming way to pass a parameter, it appears that this system knows how to pass a parameter in if the parameter is on the function. So you're calling the function without a parameter there. You're just naming it. It's a reference to the object. And the API knows that if it has arguments, you can use the arguments right where you schedule it. This is just a brilliant system. It's not data pipelining, but it is exactly what they pitch it as. It's very understandable. It is job scheduling for humans. All the stuff I'm going to have to twist my brain inside out to get here is in a much more digestible form here, except that a plain old scheduler doesn't have all the capabilities that are necessary for job pipelines. It's a lot of reliability stuff. There's job queues in there to make sure jobs aren't dropped, all kinds of stuff. Any other questions? If anybody else has questions, it's time to get them in. Yeah, think outside the box and get you closer to your objective. If you're 2% closer, you're good with that. Yeah, it's my pleasure, Sherry. Everything is weird. Everything is more difficult than it should be. There's very little in tech that you can rely upon, especially to not change and to work that same way for the next 5-10 years. So most of the things I'm showing are long-term stable. They're broadly applicable, and they're long. That's it. They're long-term stable, and they're broadly applicable. This is what I care about most in technology, because I can't stand relearning. You know, you're starting at what, 50 to become a PhD or whatever you're pursuing. Yeah, I'm about in the same boat. I'm not pursuing a doctorate or anything, but I am 50, and I'll be 52 at the end of this month, right? So, you know, but everybody else, it's too general. So many people are starting on technology that's going to be obsoleted, and they have to relearn and relearn and relearn. This is one of the reasons I'm going slow on approaching machine learning. Had I done it a year ago, I might have ended up on TensorFlow from Google, which is a vendor trap. Now that I've discovered fast AI and realized that this guy, Jeremy Howard, is a wonderful guy. This Australian named Jeremy Howard. He wrote Fast AI. He did it with some people, but for the most part, he wrote Fast AI, and he wrote this other wonderful tool called NBDev that I use all the time. NBDev is wonderful. It lets you turn these Jupyter notebooks into pip installable packages. I write things in Jupyter Notebook that I actually push up and allow other people to get and use through the Python packaging index. PyPy.org. So the same guy who wrote this wonderful machine learning stuff that makes new stuff highly accessible to people like me, people who are not computer scientists, also wrote this thing that allows me to turn Jupyter notebooks into packages. So if you were to look for OAuth, this is probably the first example of me writing something that started out as a Jupyter notebook and then became a pip installable package, right? So where do I develop this? Where does that actually take place? If you go back to over here, and now I'm just rambling. This is so open-ended, but I think it's alphabetical. No, I have it by last modified. Let me go to alphabetical. Oh, it's upside down alphabetical. Well, there it is, OAuth. This file here. See, I wrote this here. And that is now in PyPy as this, pip install OAuth. And that is that same guy, Jeremy Howard from Fast AI, who wrote NBDev, who wrote Fast AI. Oh, and why is this so much better? There's a few reasons. First, it doesn't close you into the Google ecosystem for machine learning. It's not TensorFlow. It doesn't require you to use tensor hardware rented from Google in the cloud. You can use your game card at home. It's really strongly tied to GPUs, graphic processing units, GPUs, and those, and that's through PyTorch, right? So Jeremy Howard didn't really write the whole thing. He wrote the For Humans part of it, right? So this Fast AI is like the For Humans AI portion or addition to PyTorch, which is much more hardcore, low level. It's a machine learning library from Facebook, surprisingly. Facebook has put out some of the best stuff in the Python free and open source community, and PyTorch is one of them. Yeah, all right. This is looking good. People are dropping off, but I've rambled on enough. This has gone on for, over an hour now. And I certainly achieved my mission of getting that scheduling going. Look, it's still going there. And if I tailed that, right, I've used the command here and just put tail. Right, you always see the last 10. So since it's running every 5 seconds, I know that there it is. See, it ended at 8.9 here. So if you don't want to vim into one of these log-like files, you can tail into it, and tail will always show you the last 10. There's the 42. That was the bottom line here. It is right here. So wonderful service, right? But if you wanted to see that running with the intermittently scheduled hello world every 10 seconds as opposed to every 5, you could peek in on the service. And you know you're in a screen service here because of this stuff that I added with the dot screen. Right, see this here? I added in on an earlier video with a .screen.rc file. It's like a .vim.rc file, but it's for this screen terminal program that allows you to funnel the execution of things through a terminal session that you can log in and watch, right? For anyone who hasn't seen those previous videos, that's really what's going on here. I can control AD to detach from it. Now it's completely in the background. I can clear that, I can clear that. And I have two different, nearly identical Linux terminals connected into a container called Munchkin, which I can go to another screen here, pull this up, and go lxc list. And there's Munchkin running. Now I hate this whole long stuff. I did a video earlier. I created an alias for myself of just LX so that I can do that. But that's the same now as, and I'll just show you if I exit out and I go in here, LXC LS is too wide. So the fast parameter narrows it down by taking out the IP columns and makes it a lot better to look at, but that's too much for me to type. So I just type LX now because I created an alias for that. I did that in my profile, in my bash_profile file, which I have an alias to get into by just typing profile so you can see them. This is where I define stuff. When I type profile, it's really doing that vim of that file, bring it into an editor. And when I type LX, it's really doing LXC LS fast, right? All right. Am I rambling? Is there anything else people want to hear about? I've certainly achieved the purpose of this video. So unless someone wants to chime in, I'll wrap it up there and call this a success. I'll close my tabs. This is my habit, to give people enough time to see if there's anything I still wanted to talk about. I had to get my audio loud enough for this video. I hope the audio is loud enough. Yeah, I got so much good stuff done here. I'm going to be addressing this soon. There's absolutely no good reason to run a Python script from another via popen. That's exactly what I plan on doing. If you go over here, you'll see I'm using popen right there. And yeah, there is a very good reason to do it, because the API I'm defining to do this, to load programs externally, could run against anything. You see the Python executable is going to be Python 3.10 out of the virtual environment. The current working directory is going to be the repo. I didn't really make it into a GitHub repo. I should show that soon. And then the command is going to be, feed that file one pulse, because there's not going to be a schedule. It's just going to be the single writing out of a single pulse, a single timestamp, just a file that does a timestamp. And that will be called by the scheduler. I guess this is even another step on the scheduled stuff before I go to the data pipelining, because this allows me to call things other than simple functions that live inside Python natively, right? So anything that you could put inside a function where the scheduler lives can be scheduled. Anything that you can put in a .py file could be pulled in through an import, and its components, its component functions, could then be scheduled. Import name dot, whatever function name, and you could use those in the scheduler too. But what you can't do is whole py files to be run as if from a Python executable. But you can, using this technique, the technique that someone says there's absolutely no reason you would want to do that. Just trying to think of a reason. Okay, and that's it. I like that file. I'm going to keep that as a shortcut. I guess I just do the star. And Huey. It's all going to be about Huey in a day or so. Thanks for joining me. Hope to see you again soon. And don't forget to subscribe. And hit the bell and all those other buttons.